Alright, so second example here. The question says we have in an experiment we have 40 milliliter of 0.2 molar sodium hydroxide is titrated with 0.5 molar of C3COH acetic acid. Okay, so that means who is our titrant, who is our analyte? So sodium hydroxide is our analyte, okay, and is our strong base. Okay, it's titrated with 0.4 molar acetic acid, your titrant. That is your weak acid. Okay. So first question, we have to calculate the pH of sodium hydroxide before titration. So kenapa dia suruh calculate the pH of sodium hydroxide? Because sodium hydroxide is your analyte. Okay, so before any acid is added, we're going to find the concentration of sodium hydroxide. Okay, so when sodium hydroxide is dissociated, it dissociates into sodium ion and hydroxide ion because sodium hydroxide is a strong base. Okay, so you don't need to worry about it partially dissociating. So our punya molarity for sodium hydroxide will be 0.2 molar. Okay, so 0.2 molar. Ni 0, ni 0, ini nanti dia akan completely dissociate. So ini akan jadi 0.2, this will be 0.2. Okay, so that means the concentration of the hydroxide ion will be 0.2. So masukkan je negative log to find POH because you don't have any H plus. So you're just going to do this for your base. Alright, and then you will get 0.6989. So don't round off your value until you get your final value, okay? So then minus, you will get 13.3. So at when 0 volume of sodium hydroxide is added, your pH will be 13.3. Okay, A done. So B. Next, you're going to calculate the pH of pH of the solution after adding 10 milliliter of C3COH. So that means we need to know the mole of sodium hydroxide initially, okay, to be put in our ICF table. Okay, so to find the number of mole of sodium hydroxide, you can use the formula mv over 1000. Okay, because you have the molarity, you have the volume, and so you can find the mole. So your molarity will be 0.2. Your volume will be 10 milliliter. Okay, then you divide by 1000 because you want to change it into liter. So you will get 8.0 times 10 minus 3 mole of sodium hydroxide. So acetic acid pula, you are given berapa? 40 milliliter, that's 0.4 kan? Saya cakap ni, mabuk. So your acetic acid will be 0.4, the molarity, and the volume will be 10 milliliter. Okay, alright. Ya astaga, kenapa ni saya? Lambat sangat. 40 lah. Okay, tapi jawapan dia betul sebab saya tengah tengok reference. Okay. Alright, so ni you will have 0.4 molar times with 10 milliliter over 1000. You will get 4.0 times 10 minus 3 moles of acetic acid. Okay. So now you can plug in your values. So the initial number of mole for sodium hydroxide is 8.0 times 10 minus 3. Acetic acid is 4.0 times 10 minus 3. And this is 0. This is whatever. Okay. Your delta N will depend on the limiting reactant. So which value is smaller? Okay, the mole of acetic acid. So that will limit how much of your sodium hydroxide will dissociate. Will be left. Okay, will react. So minus. Okay, on right here it will be plus. Okay, so this one will be left with 4 times 10 minus 3. This will be left with 0. This will be left with 4.0. Okay, so that means that you can now find, you can see that after adding 10 mils of weak acid, you will have this amount of mole left in your solution. So that means you have your pH will depend on the concentration of your sodium hydroxide, because it will dissociate in water to form hydroxide ion. But your salt here, it is right here, it will not be included because you want to find the pH of the solution after adding tu. So kita tak tengok salt punya. Okay, so that one you need to find the concentration of sodium hydroxide. So for volume of solution berapa? Berapa? 10 campur dengan 40 kan? So it's 50 ml sama dengan 0.05 liter. Okay, dapat 0.08 molar. Okay, so you can find this value of your POH. It will be 1.097. Okay, for your POH. So your pH will be 14 minus 1.097, and you will get 12.9. So now you have your coordinate for when you add 10 mils of weak acid. So that will be 10 mils of weak acid. pH is 12.9. Okay, right. Next, C. We're going to predict the pH at equivalence point. Okay, ingat balik that at equivalence point, the number of mole of your acid will be equal to the number of mole of your base. Okay. So in this case, we need to first determine the type of titration that you have. It is a reaction between weak acid and strong base. That means that you will form apa? You will form a basic salt solution. Okay. So if you form a basic salt solution, that means that your pH will be berapa? Your pH jump will be atas kan awak punya pH tu. So then your pH will be 9 because your pH jump will be 7 to 11. Ingat tak? So refer back to that table if you don't remember. So the volume of your acetic acid berapa? How do you find the volume of acetic acid for equal number of mole? So you know that when So for the mole, so since mole of A must be equal to mole of B, that means that MA VA will be equal to M B V B, kan? So you can just use that formula to find the volume of your acid. Okay, so saya kira je terus, so dapat 20 mils. So that means you need 20 mils of acetic acid and your pH will be 9. So that's your coordinate at equivalence point. Okay, so next D. We're going to calculate the pH of the solution after adding 50 mils of acetic acid. Okay, macam mana nak buat yang ni? So, pH of solution after adding 50 mils of acetic acid. First, you need to find the number of moles of acetic acid since we need to do this table. Okay, you need to know that when you add acetic acid, you will get your salt and water, kan? So, your number of moles will be, we will use the formula mv over 1000. So your molarity for acetic acid is 0.4 with 50 mils. Your volume 1000, and you will get 0.02 mole of acetic acid. Okay, so just plug in your value. So tadi kita dah kira kan sodium hydroxide punya number of moles. So masukkan je 8 times 10 minus 3. So here you have 0.02. Ni kosong, ini dash dash dash. So the change in number of mole will depend siapa yang lagi sikit. Okay, so it will be your sodium hydroxide punya mole. Okay, so this one will be plus. Okay, so this will be 0. You will have no sodium hydroxide left. You will have 0.012 moles of acetic acid left, and you will have this much of salt. Okay, alright, so now that we have the number of moles for your for your acetic acid and salts, we can find the concentration of the salt and base, the salt and acid. Okay, so we're going to use the Henderson-Hasselbalch equation to find the pH value of this solution, okay, after you add 50 mils of acetic acid. Alright, so okay, so masukkan the number of moles 0.012 over 0.090. Mana dapat volume of solution? Because you added 50 mils with 40 mils, kan? So that's why your value is 90 mils. So tukar jadi liter. Right? So here you will get 0.1333 molar. Okay, for your salt, okay, your salt ada 8 times 10 minus 3, okay, over volume of solution juga. You will get 0.089 molar. Okay, now awak kan dah ada KE kan? It is given, right? It's given, so you can plug in the values. Negative log KE, berapa KE awak? 1.8 times 10 minus 5 plus log of your concentration of salt, that is 0.089 over 0.1333. Okay, so kira-kira dapat 4.57. Okay, so your new coordinate will be when 50 mils of acetic acid is added, your pH will be 4.57. Okay, right, boleh. Okay, so now that we have the coordinates, we can sketch the graph. Alright, so kumpul semua coordinates. Okay, saya tulis balik. Initial points, you have 0 and 13.3. First addition, you have 10 and 12.9. Equivalence points, you have 20 mils and 9. Okay, for pH. And then second addition, okay, masa you have excess of your acid, okay, you have 4.57 for your pH value. Right, so now awak first letak the coordinates for your equivalence point. I think this one tersalah, patutnya 20. Okay, tapi make sure awak faham je lah cara nak buat. So awak buat yang betul nanti. So ini 11 and 7. Awak punya pH jump because you have a basic salt solution, right? So the pH will be, your equivalence point will be higher than 7. Okay, and then this is your second coordinate ke berapa ni? 4.57. Oh, your second addition, right? So since you have your base in your conical flask, so that means that you will start with the base. Sekejap, saya kena lukis dulu. So your base paling tinggi berapa? It will be 13.3 at 0. Agak-agak sini 13.3. Okay, and then you have 12.9 at volume of 10. 12.9. Mana 10 ni? 12.9 maksudnya dekat 13 sini. Okay, and then you have lagi your equivalence point. Ni saya letak sini tapi dia actually 20 right? Lepas tu you have at 50 you have 4.57. At 50 you have 4.57 right here. Okay, so sekarang lukis your your graph, your curve, titration curve. Okay, boleh lah tu. Ada tak suka lah. Padam. Okay, alright. Boleh lah. Okay, macam tu. Lepas tu sambung. Okay, gitu. Alright. So since you have a weak acid kan, ni weak acid kan, so right here at this region, this is your acidic buffer region. Okay, maksudnya dia tengah try maintain dia punya pH. Okay, so dia punya slope tu konon tak smooth sangat, patutnya macam ni lah. Contoh ke? Boleh lah, contoh Okay, so remove those lines. So make sure to tell that your equivalence point is more than pH more than 7 because you have a basic salt. Okay, right? Okay, boleh So yang ni awak try buat sendiri. Mana? Ni mesti akan keluar dia punya lukisan. Tak keluar. Lukisan tu kena lukis sendiri. So yang ni kan, dia punya initial point, saya akan just bagi tahu it's 0, 1 initial point. So first addition will be 10, 1.4. Okay, check lah awak dapat buat betul tak. Second is 55, 9.26. Okay, sekejap, tengok sekejap dia punya this side. Okay. Okay. So we'll do this one now.